Hello everyone, my name is FUNG and my number matrix is BT233030424. Today I will presenting my part 1, which is compare the relative frequency and cumulative relative frequency between the production cost and profit margin. First of all, comparisons of relative frequency. The highest relative frequency for production cost is in the 30-30 range, which are 0.23, while the 70, 18, 19, 100 range are lower at 0.07. For profit margins, most of the data is concentrated in the 25 to 30 range, and the 30 to 35 range is relatively insignificant at 0.06. This showing that the profit margin have a more skewed distributions, heavily concentrated in one range, which 25 to 30, while the production costs have a more balanced distributions across multiple ranges. The second, comparisons of cumulative relative frequency. Production cost reaches a cumulative relative frequency of 1.00 by the 90 to 100 million class, while the profit margin achieve the cumulative relative frequency of 1.00 by the 30 to 35 million class. This indicating that the profit margin accumulates relative frequency much faster, reflecting the higher concentrations in fewer classes. In contrast, the production cost distributions accumulate more steady over class intervals. That's all for my presentation today. Thank you.
Hi, my name is AZRIN and my matrix number is BB233010121. I will presenting the process of calculating and interpreting the measure of central location, which is mean, median and mode for production cost and profit margins based on the data calculated from 30 manufacturing companies in Malaysia from November 2024. Okay, let's start with the first measure, which is the mean. The mean is calculated by summing all the values in the data set by dividing the total number of the observation. For example, the numbers of the observation, which is the 30 companies, and after we total up all of the values of production cost, we get 1,484.2 millions, and we need to divide by 13, which is we will get the mean for production cost is 49.4047 millions. And for profit margin, after we total up of all the values, we get 741.6, and then we need to divide it by 13. We get for profit margin is 24.72%. And for median is the median value when the data set is sort from smallest to the largest. For an even number of observation, it is the average of the two middle values. If middle values of the data set is even, we need to divide by 2. So in data set that I observe, the number is even, so we need to total up the middle value with 2. The middle value of the production cost is 43.7 and 48.8. After we divide by 2, we get the answer 46.25 million. And for profit margin, it is also even, so we need to divide it by 2. The middle values is 25.2 plus 25.5, and after we divide by 2, we get the median is 25.35%. And lastly is mode. Mode is the value that appears most frequently in the data set. And to get the mode, we need First, we need to count the frequency of each value and then identify the value with the highest frequency. And for production cost, the mode is 36.2 million. For profit margin, we have 4 most frequent value, which is the first one is 23.3, then 31.2, 30 and also 22.1. Comparison in central tendency for production cost is the mean and median tell us that most companies have moderate production costs, which is their mode shows that smaller costs like 36.2 million happen more often in the data set. For profit margin, their distribution is tighter. They have multiple modes, which is 21.2%, 33.3%, 30.0%, and 22.1%. It shows that companies' profit percentage are consistent and don't vary as much. And the relationship between the KPIs for production cost, it covers a wider range of values, reflecting differences in how much the company spends on operations. And for profit margin, they are more closely grouped, meaning the profitability levels across companies are more similar. In summary, the production costs show more variability while the profit margins are steady, giving us a clear picture of operational efficiency and profitability pattern. I think that's all from me. Thank you.
My name is NURFAEJAH BINTI BAKAR, BB2330480. I will present part 3, which is about box plot. First of all, in box plot, there will show 5 important points, which is minimum value, Q1, Q2 or median, Q3, and the last is maximum value. As we can see at the production cost diagram, the minimum value is 11.8 and the maximum value is 97.2. The Q1 and Q3 value we get after we calculate the percentile 25 and 75. There is no outlier because all the observation inside the range, which is between negative 35.43 and 129.58. All the median, after all, the median down a little bit to the bottom of the box, and the whisker is shorter on the lower of the box, so this is a positively skewed. Same goes with profit margin diagram. The value Q1 and Q3 we get after calculated percentiles, and the minimum and maximum value state like in the list provided beside the diagram. There is no outliers too because the observation given inside the range, which is 13.29 and 36.19. The median closer to the top of the box and the whisker is shorter to the upper of the box. So this is negatively skewed.
Hello, my name is Shasha ROZAINIE binti MOHMAD. My matrix number is BB2330349.
I'll be presenting part 4 of our analysis, which focuses on range, mean, absolute deviation, variance, and standard deviation. First, we have the range, which measure the difference between the highest and lowest value in each data. For production cost, the maximum value is 97.2 million and the minimum value is 11.8 million, giving us a range of 85.4 million. For profit margin, the maximum value is 31.2% and the minimum value is 60.3%, resulting in a range of 13.7%. Instead, as the product costs vary significantly more than profit margin, suggesting potential inefficiency or large-scale operation in cost management compared to the relatively stable profit margin. Second, next, we calculate the mean obsolete deviation, which is MAD. This metric shows the average distance of each data point from the mean. For product cost, mean is 49.47 million. This large deviation highlights the significant fluctuation in product cost. For profit margin, MAD is 34.72%, indicating more consistent profitability across the dataset. For example, product cost might fluctuate due to varying style of operation or unexpected expenses. Their profit margin remains stable despite this fluctuation for stability due to effective pricing strategy. Now let's look at variance and standard deviation, which measure how spread out the data points. For product cost, the variance is 6.10 and the standard deviation is 35.42 million. This high value confirm that production costs are widely differs from the mean. For profit margin, the variance is much smaller at 14.21, which standard deviation of 3.77%. This shows that profit margin cluster more closely around the average value. For example, this means typical production cost can vary by approximately 35.42 million, whereas a typical profit margin deviation is just 3.77%, emphasizing the stability of profit margin. Finally, the coefficient of variation is CD, give a standardized measure of variability by comparing the standard deviation to the mean. For product cost, the CV is 51.38%, meaning that variable is over half of the average product cost. For profit margin, the CV is just 7.62%, showing much less variability relative to the mean. The takeaway here is the product costs are highly unpredictable compared to product margin, which are relatively consistent. This variability in product cost might be a key area to address for improving efficiency. Thank you.
Hello to Ms. Chua. My name is Esther RONY and my matrix number is BT2330352. Today I will present about chapter 5, which is covariance and correlation coefficients. First, to calculate covariance, we need mean number to calculate it. Here mean for production cost is 49.47. However, mean for profit margin is 24.72. After we get the mean number, we will calculate to we will calculate for covariance. Here my value for covariance is negative 86.65. So after we get the value for covariance, now we can calculate for correlation. My value for correlation is negative 0.90. In this conclusion, the covariance value show that the value is negative. This lead to negative covariance. The negative means that relationship between product cost and profit margin is negative. However, the value for correlation is negative 0.90, which is close to negative 1. This shows that relationship between product cost and profit margin are strong linear relationship. That's all for me. Thank you.